So here is the solutions to the take-home quiz. Next week I'm going to be giving you a review, and I'm also going to be giving you a momentum test. Your momentum test is going to be probably the front and back of one piece of paper, so technically 2 pages, and I think 4 questions, and I'll tell you way more information about that in an email. But here's your hint. Look at both of the quizzes for some advice on what you might see in the future. Name, good old Anne. And here we go. Number 1. So we have a collision. This is a job for conservation of momentum. So you can say the sum of all the momentum we started with equals the sum of all the momentum we finished with. I see north and south. I'm going to call north positive. I'm going to call south negative. I'll call this mass A. I'll call this mass B. And so I have, before the collision, mass A, velocity A initial, and mass B, velocity B initial. Wham, they collide. They stick together, so it's going to be mass A plus mass B, V final. Now this question wants us to find V final, and I'm good with that. I would also have no problem giving you V final and asking you to get this velocity or this velocity by itself. So that would be asking how fast was one of the players running before the collision. To get V final by itself, it's going to be mass A plus Mr. Dueck times VA initial plus mass B, VB initial. Remember to pay attention to directions, all over mass A plus mass B. Mass A, 82, 7.5 plus 65, negative 8.1, all over 82 plus 65. Now, by the way, it's possible this could work out to 0, and that would just mean that these players had collided and exactly canceled out each other's momentum and come to a stop. Could happen. 82 times 7.5 plus 65 times negative 8.1. Close off the top, divided by 82 plus 65. These are 2 football players running at each other. Who's going to win this collision? I got a positive answer, so player A wins this collision. He is able to push player B back a little bit. And I get 0.602 meters per second, and for a direction, north, because I got a positive answer. Double check to make sure I didn't make a typo. That looks good. So in terms of part marks, if you got the right answer, I would give you 3 out of 3. Otherwise, I would give you a half mark for the magnitude, half mark for the direction. I would give you, I think, half mark if I saw that, half mark if I saw that, half mark if I saw that, and then a half mark for the numbers. If you missed the negative, you would get 7.77, and I would give you 2 marks. Okay. Number 2. Okay, now we only have one object. This is not a collision or an explosion, and they're talking about impulse. So I'm going to be thinking about the 3 impulse equations. So the first thing they want me to find is the impulse. Well, impulse is change in momentum. I see 2 velocities, so I'm going to use mv final minus mv mv initial. Except since we're rebounding, I'm going to call upwards positive, and I'm going to call downwards negative. So that's going to, oh, and 52 grams, nice try, 0.052 kilograms. So it's going to be 0.052, 6.2 minus 0.052, negative 8.2. I'm going to have a minus minus here, which is going to be a plus. 0.052 times 6.2 minus 0.052 times negative 8.2. And I get an impulse of 0.736. No, I got a typo. Let's try that again, Mr. Dueck. 0.052 times 6.2 minus 0.052 times negative 8.2. I get 0.7488. 0.749 kilogram meters per second. Just got to pause the video for 1 second. So if you got that right, oh, and if I wanted a direction, I'll put the direction up if you didn't include a direction. Oh, it did say magnitude and direction, yes. So I would give you half mark for the magnitude, half mark for the direction. I would give you a half mark for that, and I would give you a half mark for the numbers. But if you got the right answer, 2 out of 2. Now, if you missed the change in direction, so you missed the negative, then you would get negative 0.104. So I would say this, 1 mark for 0.104, positive or negative, because it depends which way you let be positive, which way you let be negative. What's the average force? Now, I could find this by calculating the acceleration and then going F equals ma, and if you did that, full marks, but I could also go impulse equals force times time. So force is going to be impulse over time. It's going to be 0.74, what was the actual value? 88, divided by, what was the time? 0.15 seconds. Oh, sorry, 0.7488 divided by 0.15 seconds. And I get 4.99 newtons, and they wanted a direction. Well, up. Half mark for the magnitude, half mark for the answer, half mark if I saw that, and a half mark if I saw that. If you got the right answer, though, 2 out of 2. Number 3. This is a collision, but there's only one object. So even though it says collision, the fact that they're wanting me to find the average force, this is a job for impulse. In fact, I think I'm going to say this. I'm going to walk through the steps I did in question 2, but I'm going to do it in one line. So I'm going to start out by saying impulse equals impulse, which sounds really silly, but really what I'm going to say is force times time has to equal mv final minus mv initial. And then if they want me to get the t by itself, sorry, the force by itself, now the key to notice is that there's a change in direction. So I'm going to let, oh, I don't know, to the right be positive, and to the left be negative. So if I get a positive answer, that'll be to the right. If I get a negative answer, that'll be to the left. So I get this, 1,650 times negative 1.3 minus 1,650 times positive 11. I'm going to get a negative answer, and I should, because the change in momentum is definitely to the left, and the force is definitely to the left because the wall is bringing this car to a stop and then pushing it back in the opposite direction. The time is 0.3 seconds. Bracket 1650 times negative 1.3 minus 1650 times 11 divided by 0.3. And I get, does this look right, Mr. Dueck? Did I make any typos? Times negative 1.3 minus blah, 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 times 11. But, yep. So I get negative 67,650 newtons. They said the magnitude of the average force, so I'll take plus or minus 67,650. I'll call it 67,700 newtons if I go to 3 sig figs. In terms of part marks, I would give you a half mark for the answer. I would give you half mark if I saw that, half mark if I saw that, and a half mark for the numbers. Okay, now we have two masses. This is an explosion. This is a job for conservation of momentum. The total momentum we start with has to equal the total momentum we finish with. Before the explosion, before we pulled the trigger, what's moving? You know what? I'm going to call this mass A. I'm going to call this mass B for bullet. That works well. And I'll call north positive. So before the explosion, nothing is moving. So there's no momentum. After the explosion, we're still going to have zero momentum, but that's going to be made up of the momentum of object A and the momentum of object B. They want me to find the recoil velocity of the rifle. They want me to find the velocity A, so it's going to be negative mass B, velocity B, divided by mass A. That equals the velocity of A. It's going to be negative 0.046, positive 490, divided by 2.4. If I get a positive answer, that'll be north. I'm going to get a negative answer, as I should, because if the bullet goes north, the rifle recoils south. I get negative 0.046 times 490 divided by 2.4. And I get negative 9.39 equals 9.39 meters per second south. For 3 marks, I would give you half mark for the direction, half mark for the magnitude. I would give you 1 whole mark if I saw that line somewhere. You know what? I did say I would give you a half mark just if you wrote down that it was conservation of momentum. So I would go like that. I would go half mark for that equation, and then a half mark for the numbers, and there's your 3 marks. Oh, I see 2 people. Here's a collision. You know what? I'm going to use G for George and J for Jim, just because that's easy. East is going to be positive. West is going to be negative. Positive. The total momentum we start with has to equal the total momentum we finish with. Before the collision, we have mass George, velocity George initial, mass Jim, velocity Jim initial. They collide, they don't stick together, so I have mass George, velocity George final, plus mass Jim, velocity Jim final. They want me to find the final velocity of Jim. I think I'm going to minus this over to that side, and then divide by mass J. I'm going to get lots of room. Hey, I got a whole page. Good. Mass G, velocity G initial, mass J, velocity J initial, minus mass G, velocity G final, all divided by mass J. that's going to be the final velocity of Jim. So we're going to get 85 times 14 plus 65 times negative 8 minus 85 times 4, all divided by 65. Definitely need brackets around the top. Bracket 85 times 14 plus 65 times negative 8 minus 85 times 4. Close off the top, divided by 65, and I get, so it looks like in this collision, George keeps moving forwards, although he slows down from 14 meters per second to 4, and Jim, who was going south, or whatever we're going to call it, gets pushed backwards and ends up going backwards at 5.1 meters per second. I'll go to 3 sig figs. 5.08 meters per second. And I got a positive answer. And so positive means east. If you got that, 3 out of 3. Otherwise, I would give you half mark for the answer, half mark for the direction. I would give you a half mark if I saw that, half mark if I saw that, half mark if I saw that, and a half mark for the numbers. If you missed the change in direction, so you missed that negative, I would give you only half the marks. I would give you 1.5, and you would have had 21. So I would say this. 1.5 out of 3 for V equals 21 meters per second. Arrow. Ooh, I see 2 objects. I see a target. I see an arrow. I see it sticking. This is a collision. This is going to be conservation of momentum. Oh, but they stick together. They stick together. So this is an inelastic collision. The sum of all the momentum we start with equals the sum of all the momentum we finish with. I'm going to call this mass A, and I'll call this mass T for target. And I'm going to call west positive. So before the collision, all we have moving is the arrow. Wham, they collide. After the collision, we have them stuck together. V final. Oh, this isn't going to be too bad. They want me to get the V final afterwards. I can totally do that. V final is going to be the mass of the arrow, velocity of the arrow initial, all the momentum of the arrow, divided by, since they stuck together, now that momentum has to move both of them. It's going to be 0.12 times 105, pretty fast bow and arrow, but not crazy fast. Probably a compound bow or something like that. 0.12 plus 0.8. And I get 13.7 meters per second. Magnitude and direction, I got a positive answer. Got to be west. 3 marks if you got that. Otherwise, I would give you a half mark for the magnitude, half mark for the direction, Half mark if I saw that. Half mark if I saw that. It's getting fairly familiar. How do I give out the part marks? And there you go, my angels. So, I'm going to be giving you a review assignment next week. Your test will be the week after. If you're wondering what your test is going to look like, probably 1 or 2 impulse questions and 2 or 3 collision, explosion, conservation, and momentum questions.